it's June the 8th, 11:37 p.m. I rewrite this problem to use a fixed size sliding window. So let me restart this problem. So I need to check if any permutation of S1 exists as a substring of S2. So a permutation has the same character with the same frequency, just in different order. So really I'm looking for a contiguous window in S2 where the character counts exactly matches the S1's character counts. Since a permutation of S1 is always the length as S1, so this window is fixed size. We call this is a fixed size window with size S1. So since the and for data structures, I will use two hash map. One is need. So this is going to capturing the feature of string S1 with the characters as well as its frequencies. And another one as windows to record what is in the current window. And I will also have a variable called required. So required is it will have the length of need. It will record the number of distinct characters in S1 and have, that means how many, this will count how many characters currently have the exact required frequency. Okay, let me make sure. So the required will tell the number of distinct characters in S1, and have is count how many characters currently have the exact required frequency. So when the have equal to required, that means we have found a valid permutation. So we can first build the need. So for character and S1. And for the algorithm, I will go over I'll go over S2. With the right pointer, and each step I'll just add the right character into the window. I'll just record the red character into the window. So I wanted to read it into the window. I will read the red character into the window if it's in need and it can't just match our increment have. And for the shrinking part, so that's the increment part. And for the shrinking part, if the window just if the window size exceeds k, I'll remove the left character. Okay, we continue. At this point, we are going to just decrement it in the window. And we check if after decrement window, if it is in need, and after the decrementation, okay, I'll be alright. So here, look at this. We have already in this step we got the we have updated the window, and if we found that this is smaller than the need frequency, we simply decrement half. Okay, so after this f, that means that we have already had a fixed size. At least this is one that has the fixed size, and we try to say if the half equal to need. If it is, that means that we have found a permutation. If not, we just check later ones, and if later we didn't found, that means there is no valid permutation. Okay, there's a problem here. Let's see. The force. Okay, so let me see. Oh, I think this one has the problem. I need to check just LC, left C. This should compare with required. And I think a very common thing that I always made, mistake I always made is that I always forgot to, every time this happens, I should always update the left. And also, there's some logical problem here. It's made for one time, but if right minus left plus 1, so this is the left. So we wanted to check first before we increment or decrement. Let me see why this happens. So, for the shrinking part, I basically first check if window LC is smaller than need LC. If a character has never been enough to get the need, so my approach is first, this part has a problem, so my approach would be first check if LC is in need, and if window LC equal to need LC. If it is, that means we have to minus the have. Okay, this time it works.